Today we're going to discuss a topic related on electric vehicles. We are looking at the website from AUTOSAR.org that defines the specifications for electric cars. Scrolling down, in the latest release of these specifications, as of this recording, is now at revision 23. And beside this are PDF documents that describes these specifications. All member of AUTOSAR must follow the specifications in order to comply with the AUTOSAR guidelines. Part of this specification is the use of the C++ programming language as the official implementation language for electric cars and guided by or protected by the ISO 26262 safety critical definitions and guidelines. Now, the a piece of code for of an electric car has many components, but we will be focusing on the core communication subsystem of the ARA layer or the adaptive runtime application layer, which follows that the vSomeIP protocol. There is an open source implementation of that protocol here, and vSomeIP is one of the reference implementation. I cloned this repository and created a branch, dxlab. Under the README of this branch, I describe the steps and how to play around with this piece of code to build in Visual Studio. In addition, I will show the use of a static analyzer from Parasoft to assist and aid in an analysis of a massive piece of code that has many components and composed of thousands of files. So these are the steps, and let us begin. First, we will open the developer command prompt for Visual Studio, and we will clone this repository. We have to switch to the dxlab branch. Now that we are in the branch, we need to download the Boost library. I already made the download here. And we will be using specifically in this session the Boost 1.74.0 version. I will set the Boost root DOS environment variable. You will notice that I set an environment variable that mentions Google Test. As it stands, the Google Test is the default unit testing framework in this vSomeIP reference implementation. After setting these variables, we create a build directory, build, then CMake. Next, we open Visual Studio and then load the generated solution file. The Visual Studio 2019 that I am using here has the Parasoft C++ test plugin installed. That is why you can see uh, this Parasoft menu here. Let's wait for the project to load first. It is a big project. That's why it takes time to load. Right. So because of I installed the Parasoft plugin, what I'm saying is we can see this Parasoft menu here. Parasoft is a static and dynamic C++ analyzer tool, and I will show some benefits that we can derive from using these kinds of tools. Static analysis, by the way, is part of the compliance required by ISO 26262 for any software written for safety critical applications such as electric vehicles. In fact, if we go to the Parasoft menu here and go to the test configuration, aside from electric vehicles, the Parasoft compliance tool also supports aerospace requirements, automotive pack, this Mesra, medical devices, security pack, and so on. So we will be focusing on the AUTOSAR aspect of static analysis using this piece of code from adaptive platform. Now, the first challenge here is to build this huge code base. Let me go back to the README. We need to set the platform toolset, and we need to build these DLLs and executable. So if we go here, select application test as the startup project. This is the Google test main application, but the DLLs are this one. Let me do some build now. First, let me set the platform toolset to B142. Let me try to let's build the library first. Let's build the second one. Third one. The service discovery is the you can see a lot of boost dependency here. Without boost, this application will not work. So this is very tightly integrated to boost. And then let's try to build the main Google test application first. We might encounter some, okay? So we have to set the platform tool set of this one. This one is no dispatch reach JSON, followed by copy application test. Threads daemon JSON starter. So let's build again. Um, copy application test starter. This one. Copy application test daemon JSON. Build again. Oh, what is this? G-test. It's down here. Google test is cloned as a result and included in the build. This is just how they design it. There. Then build again. Okay, so we have successfully the core components. These core components are comprising of these uh, DLL, SomeIP configuration, E2E, service discovery, and the core SomeIP protocol. We also need to copy the Boast file system DLL beside the application test.exe for obvious reasons that it just need the DLL beside it to execute. So if we go here, vSomeIP, and go to build, we built the executable, the Google test application, and then the DLLs, the core DLLs. Uh, we will need to copy these DLLs beside the exe. So let me do that. Um, wait. Okay, debug. So now this test exe have the needed DLL beside it, so it should be able to debug. Otherwise, we cannot debug it. So opening up the Visual Studio, and since we set application test as the starter project, we can therefore put a breakpoint here. And then as part of the Google test flow, it will invoke the constructor and in the setup, and then successively the test cases here. I will press F5 now. So this is Google test way of testing the software. It is the default unit testing for vSomeIP. I'll press F5. So we proceed to the constructor. I'll press F5 again, and here. So the runtime is first the according to the protocol of adaptive AUTOSAR. In the implementation of it, if we F11 and there, and so we will be tracing deep into the implementation of this protocol. So this is one of the benefits for Visual Studio is the extensive debugging and allowing the developer to understand the workings of a piece of software. Let me press the stop button here. We go back to the test app. This is the Google test. Because we have the Parasoft static analyzer in this IDE, we can select any subsystem here of the of the implementation. For example, not this one because these are Google test generated. I will select the maybe this one response request sample. So the piece of code first we'll take a look. So this is that piece of code which exercises the vSomeIP protocol, and then let us select the request sample. Right click. You will notice the Parasoft menu here because we installed the Parasoft as a plugin in Visual Studio. Go to test using built-in and then static analysis. You have the option to choose which rules to analyze against. The tool provides some default selections. For example, the effective C++ selections consisting of many rules inside this selection. So you will select this. So we are now statically analyzing the request sample subsystem of the vSomeIP implementation according to effective C++ rule sets. It found 4 violations. Then here they are. In the request sample, constructor does not initialize session. Interestingly, double click this, and yeah, that is how it looks like. And so that is how it looks like uh, a, using a static analyzer. We can continue to, but I don't recommend to analyze the whole thing because that will be counterproductive. Just start analyzing small pieces of code first, like here in vSomeIP. Okay, This one looks right click, properties, Parasoft, test using static analysis, effective C++. Might take a while because this one has many files. So while the analysis is going on, you can go to the view output, and then this is the current run of the analysis. Finished. Is it finished? Okay, let's see what it found. 522 violations. So the a static analyzer can therefore allow you to quickly make sense of a big piece of code because it points to the really to the deep parts that may contain uh, some errors, and you need to check these places. Okay, so let's go. Let me check these. So we can see here that most of the boost dependency is in the implementation portion of the software. Let's see. So they are centralized there. Okay, you can see here the boost is heavily used. The async IO, TCP, UDP, stream protocol, all relies on the boost implementation. So this is all for now, and the quick gist here is you cannot just clone this repository from master and build, expect it to build. Because it is a moving target, it might have some breaking modifications, and that is why I have to clone this, my own copy, and create a branch that I knew I was able to build at some point in the past. So this will be a good exercise for those who want to get into automotive development by starting at the core communication subsystem of adaptive AUTOSAR, which is the ARA or adaptive runtime application. And I recommend to also read the PDF in the published in adaptive AUTOSAR.